How do you write complex numbers in polar form? Any complex number z can be written in polar form, which is r times the cosine of theta plus I times the sine of theta, where r is the norm of z and theta is the argument of z. Let's investigate why this makes sense by looking at a general complex number, z. Z equals a plus b times I, and has the coordinates a comma b in the complex plane. Think of z as a vector starting from the origin to the point at a comma b. Now imagine drawing a line from the end of the vector down to the real axis, like this. You may again notice that z and its components form a right triangle with legs of length a and b and a hypotenuse r. This hypotenuse is the norm of z. The vector also forms an angle, theta, with the positive real axis. This angle is the argument of z. Now you want to rewrite z using r and theta instead of a and b. Let's study how the expressions a plus bi and r times the cosine of theta plus I times the sine of theta are related by using some trigonometry. You know that the sine of theta equals the opposite leg over the hypotenuse, or b over r. This means that b equals r times the sine of theta. You also know that the cosine of theta equals the adjacent leg over the hypotenuse, or a over r. This means that a equals r times the cosine of theta. Next, let's replace a and b in the equation z equals a plus bi. You get that z equals r times the cosine of theta plus r times the sine of theta times I. By factoring out r and rewriting the last term, you end up with z equals r times the cosine of theta plus I times the sine of theta. Let's look at an example. Write z equals minus 1 plus the square root of 3 times I in polar form. To do this, you first need to find the norm and the argument of z. Let's start with the norm. R equals the square root of a squared plus b squared. Here, a equals minus 1 and b equals the square root of 3. So, r equals the square root of minus 1 squared plus the square root of 3 squared. Minus 1 squared is 1, and the square root of 3 squared is 3. 1 plus 3 is 4, and the square root of 4 is 2. Next, let's use cosine to find the argument theta. The cosine of theta equals a over r, which equals minus 1 over 2. So, theta equals the arc cosine of minus 1 over 2, which is either 2 pi over 3 or 4 pi over 3. Now, let's use sine to check which is the correct argument. The sine of theta equals b over r, which equals the square root of 3 over 2. So theta equals the arc sine of the square root of 3 over 2, which is either pi over 3 or 2 pi over 3. Since both expressions give 2 pi over 3 as a value, that is the correct argument of z. Finally, let's use the norm and the argument to write z in polar form. Z equals 2 times the cosine of 2 pi over 3 plus I times the sine of 2 pi over 3. Nice! You've now written a complex number in polar form. Any complex number z can be written in polar form. Z equals r times the cosine of theta plus I times the sine of theta, where r is the norm of z and theta is the argument of z.